Hi, and today we are going to learn how to find the complementary functions for nth order linear differential equation which is homogeneous. So, complementary functions. So the differential equation, if the differential equation is of the form dny by dxn plus a1 times n minus 1 times y dx to the power n minus 1 plus a2 times dn minus 2y upon dx to the power n minus 2 till an times y is equal to q of x. So if q of x is equal to 0, then this equation will be called as nth order linear homogeneous differential equation. And if q of x is not equal to 0, then this equation will be called as nth order linear non-homogeneous differential equation. And our main motto is to find the complementary functions of this linear homogeneous differential equation. So let's take our first example. So d2y by dx to the power 2 minus a2y is equal to 0. If we compare this given equation with the standard equation, so here q of x is equal to 0, so this will be called as second order linear homogeneous differential equation because the order is 2. Now in order to reduce the time, what we are going to do is we are going to write d by dx as capital D. This is just in order to reduce the time of writing. So d2 by dx square will be equal to d square. So we are going to follow this rule in all our problems. So this equation can be written as d square times y minus a square times y is equal to 0. So if we take y as common, so d square minus a square times y will be equal to 0. And now here d square minus a square is equal to 0 is called our auxiliary equation. And now we are gonna find the root of this equation. So d square is equal to a square and d is equal to plus or minus a. Now watch after this. So consider the table. So if roots are real and distinct, that is real and unequal, then the complementary function yc is equal to c1 times c to the power m1x plus c2 times c to the power m2x. And if roots are real and equal, then the complementary function yc is equal to c1 plus c2x times c to the power m1x. And if there are three roots, and if roots are real and equal, and if there are three roots, then yc will be equal to c1 plus c2x plus 3x square times c to the power mx. And if roots are complex, then a complementary function will be equal to e to the power alpha x times c1 cos of beta x plus c2 sine of beta x. So here the roots are plus a and minus a, which implies that the roots are real and unequal, means distinct. So here our complementary function yc is equal to c1 times e to the power ax plus c2 times e to the power negative ax. So this is the complementary function for the given differential equation. Let's take another example. So our next example is d3y by dx cube minus 9 times d2y by dx square plus 23 times dy by dx minus 15y is equal to 0. And as I told earlier that in order to reduce the time of writing, we are going to consider d by dx as capital D. So d3 by dx cube will be d cube, so it will be d cube y minus 9 d square y plus 23 dy minus 15y is equal to 0. Now we are going to take y common from this equation. So d3 minus 9 times d square plus 23 times d minus 15 times y is equal to 0. Now our auxiliary equation will be d cube minus 9d square plus 23d minus 15 is equal to 0. Now we are gonna find the roots of this equation. Here we have the simple technique to find the roots. So the coefficient of d cube is 1, coefficient of d square is negative 9, coefficient of d is 23, and the constant is negative 15. So first we are gonna try by dividing this by 1, so this will be 1 in the bottom. So 1 times 1 is 1, and minus 9 plus 1 is negative 8, so negative 8 times 1 is negative 8 and this will be 15. So 15 times 1 it's 15, and we got 0, means d is equal to 1 is our one root. Now in order to find the another roots, what we are gonna do is, this belongs to this square, this belongs to the power 1 of d, and this belongs to constant. So d square minus 8d plus 15 is equal to 0, and by splitting the middle term we can write this equation as d square minus 5d minus 3d plus 15 is equal to 0. And now what we are gonna do is d square, we are gonna take d common, d minus 5 minus 3 d minus 5 is equal to 0. Let us verify this. D square minus 5d minus 3d plus 15. So d minus 3 is equal to 0 and d minus 5 is equal to 0. So d is equal to 3 and d is equal to 5. So we came up with these 3 roots, and these 3 roots are real and unequal. So our complementary function will be equal to c1 times e to the power 1 times x plus c2 times e to the power 3 times x plus c3 times e to the power 5 times x. So let's take another example. So d square minus 2d plus 1 times y is equal to 0. Here our auxiliary equation will be d square minus 2d plus 1, it will be equal to 0. So by splitting the middle term we can write this equation as d square minus d plus 1 is equal to 0. So if I take d common, so d minus 1 minus 1 d minus 1 will be equal to 0. Let us verify. So d square minus d plus 1, okay, it's correct. So d minus 1 equal to 0 and d minus 1 is equal to 0. So d is equal to 1 and 1 are the two roots. Now these two roots are real and equal. So the complementary function yc is equal to c1 plus c2x times e to the power 1 times x. So this is the complementary function for the given differential equation. So let's take another example. So d minus 1 times 3 to the power 3, sorry, times y is equal to 0. So we can write this equation as d minus 1 square times d minus 1 times y is equal to 0, and from this term it is very clear that d is equal to 1 is our one root, and we can write this equation in the form of a square minus 2ab plus b square. And now we can split this equation by, so this will be d minus 1 equal to 0 and d minus 1 is equal to 0. So there will be three roots as the power is 3. So d will be equal to 1, 1 and 1. So here we are found that these three roots are real and equal. So our complementary function yc will be equal to c1 plus c2x plus c3x square times e to the power 1 times x. Let's take another example. So fifth one is d plus 2 bracket square times d minus 1 times y is equal to 0. So from this equation we have got our one root, that is d is equal to 1, and we can write this term as a square plus 2ab plus b square. So d square plus 4 times d plus 4 is equal to 0. So we can split this equation as d square plus 2d plus 2d plus 4 is equal to 0, and if you take d as common from this term, so d plus 2 plus 2 d plus 2 is equal to 0. It's d square plus 2d plus 2d plus 4. So d plus 2 is equal to 0 and d plus 2 is equal to 0. So we came up with d is equal to 1, negative 2 and negative 2. So here our complementary function yc will be equal to c1 plus c2x times e to the power negative 2x, because here we have two roots which are real and equal, and another root is real and unequal. So this will be c3 times e to the power 1 times x. Let us take another example. So d2y by dx square plus dy by dx plus y is equal to 0. So this can be written as d square y plus dy plus y is equal to 0. So if we take y common, we can write this equation as d square plus d plus 1 times y is equal to 0. So our auxiliary equation will be equal to d square plus d plus 1 is equal to 0. Now we can't solve this equation by splitting the middle term. So what we are gonna do is we are gonna use this general equation. So minus b plus or minus and root b square minus 4ac divided by 2a. So this will be minus 1 plus or minus under root b square minus 4ac divided by 2. So this will be negative 1 plus or minus under root 1 minus 4 divided by 2. So this will be negative 1 plus or minus under root, so 1 minus 3 is negative 3, so this will be our imaginary part, so 3 times I divided by 2. So this can be written as negative 1 by 2 plus or minus root 3 times I. So this is in the form of alpha plus or minus I times beta, and for this the complementary function yc will be equal to e to the power alpha x inside the bracket c1 cos of beta x plus c2 sin of beta x, so which will be equal to e to the power alpha is negative 1 by 2x inside the bracket c1 cos of root 3 by 2x plus c2 sin of root 3 by 2x. So this is the complementary function for the given differential equation. So this was all information regarding how to find the complementary function for nth order linear homogeneous differential equation, and thank you for watching this video.